Good afternoon. Today we are working on packet number 3. The video is due on November 7th. On our first page, we have 4 digits that we need to place into our 4 boxes to make these equivalent fractions true. 3/6 equals 9/18 equals what fraction? Needs to be equivalent. So you only have those 4 numbers to place in those boxes. When I was making my answer key, to be honest, I guessed and checked some and said, oh, I think it's going to be this fraction. And I went, oh, wait, nope, that doesn't work. And I said, oh, let's check this fraction. Oh, wait. And then I actually found a shortcut to it that I'm not going to tell you because it's going to make it too simple. But you can guess and check, make sure that they are equivalent fractions. Second page. Henry is in the kitchen baking. Ooh, Henry, I hope you bring these muffins in for us. So, Henry used half of his flour to make blueberry muffins and half of the remaining flour to make tofu muffins. He has 1.5 cups of flour left. How much flour did he start with? So there is mathy ways that we can do this with our fractions, but when I come to a word problem, if I don't automatically know how to do it, I do a picture. So I'm going to say this is how much flour Henry starts with. I know that he used half of it to make his blueberry muffins, and then he used half of the remaining to make his tofu muffins. And Henry, I prefer blueberry over tofu, just side note. He has 1.5 cups of flour left. Well, this is how much he has left, and that's 1.5 cups of flour. So if that's 1.5 cups, what's the other half going to be? 1.5 cups, right? Because it was half of his flour and half of the half was 1.5. So the other half has to be 1.5. So how much is this half of his flour? So if you figure out how much half the flour is, you should be able to put that in for this half. So if you know this half of the flour, you're going to know this half of the flour, add it all together for the total that he started with. So like I said, I did see some people who had me check it, knew how to do the mathy working with the equations. That's great. Some of us are not quite there yet with the word problems. Draw a picture. Fill in the information you know, and it's going to help you with the information that you don't know. Next page is our 5-card challenge. Here are some things to make note of. You can only use these cards when we're making our equations. What card do we have to have in order to be able to do a square root? Jude? A 2. So if there's no 2 up here, you cannot do a square root. Okay, so some of us were saying, I forget how we were going about getting it, but some of us were trying to use the square roots. We can't use it if there's no 2. Little challenge for y'all. I do know that there's an 8th grader really challenging herself on this one right in particular. And she has over 1,000 points so far.
What? I can never get past 20.
So I know years and years ago, I had a student named Aiden Thomas in kindergarten. And then when he was super smart in kindergarten. I like to think I taught him everything he needed to know in kindergarten. Because by the time he got up to Mr. Schultz in middle school, I think his top score was like 800 or 900 some points on this. And Andrea's mission in life is to beat Aiden Thomas's score. So Mr. Schultz has to go through and check and make sure that they're all legitimate equations, which I'm sure the majority of them are. I mean, you can challenge yourself to get way more than the 15 points that pre-algebra has to get. This works on our number sense. This helps us to understand the numbers even more and will help us with future math. Grace.
Is it all one version
Oh, no, you can only have 5 cards in an equation. So the most points you can get for an equation is 5. So she's got so much, she showed me her packet and she had a bazillion equations written down on her page. Like just a ton, one right after another. So you can only have 5 cards. That's the most you can have in an equation because you can only use each card one time. Okay.
Did you have to grab like scrap paper?
Oh, I'm sure she did. Peyton.
I got 23.
Nice. Nice.
27.
So we know geometry needs to have 21. Challenge yourself to at least get to the geometry. Some people have been getting more. Some people have already been challenging themselves in here. Shh. Okay, friends, this is a video, so let's stay focused. Shh. For our pattern page, Pre Algebra needs to complete the table through figure number 7. So we need to complete that whole top part of our pattern. Let's start filling in our table. How many reds in figure 1? How many blues?
2.
How many purples? Total. Figure 2, red, blue, purple. Total. Figure 3, red, blue, purple. Total. 9. Figure 4, red. 8. So they added 7, but you also have to count the red that's on the inside. So there are 8 reds. You have to count all of the reds. How many blues? How many purples? How many total?
16.
So, first thing I did, can you wait? Oh, so is it what? Okay, can you wait till we're done with the video? So, first thing I did was I remembered my patterns. How many do I have in a row before I change it? 3. So I had 3 1s, I'm gonna have 3 8s. I already have 3 3s here and I'm not sure what's gonna come next. How many 5s do I need to see? I need to see 3 of them. And then it'll change. It changes every third figure. So now I'm going to look at my total blocks. There are 2 different ways that you can solve the total blocks without having to count up all the reds, blues, and purples. What's one pattern that you saw for the total blocks? Did anybody find a pattern for it? Matthew?
So, like, if you add 7, you could just add 7 to the last one. Paul?
I'm looking at the total blocks. This was, I added 3.
Yeah.
This was, I added 5. This one, I added 7. Are we going to add 7 again? I would add 9 because I'm going up by those odd numbers. So, friends, here's something with these pattern pages. My favorite kind of numbers are on it. Perfect squares. A lot of times we see them on the pattern page. So if we look at this, we see 1, 4, 9, 16. Figure 1, 1 squared, 1 times 1 is 1. 2 squared is 2 times 2, that's 4. 3 squared is 3 times 3, that's 9. 4 squared is 4 times 4, that's 16. What am I going to do for the next one? 5 squared is going to be 25. If you know 3 of your numbers, can you figure out what your missing number is? Yeah. You take your total and you subtract out the 2 that you know, and you're left with that one. And then you can fill those in. And then you're going to have one empty one. And you're going to figure it out that way. Process of elimination. Eliana. Yes. Thank you. Henry.
I actually went all the way through 10.
Awesome.
I also noticed the 3, 5, 7.
Yeah. On my answer key, I just kept going myself. So I went through 10. I will only mark it as wrong if it's from up to 7 you got wrong. But I will check it if you go up to 10 because I have it on my answer key. Addie.
I think you missed the first page. Because I don't remember you going over them.
I did.
I did.
The one with the fractions that I said were equivalent fractions.
Oh, yeah.
Okay, next page. Perimeter and area. First thing you have to do to find the perimeter is to make sure that you fill in every side with a measurement. So figure out your missing measurements, add them up. Then to find our area, we know the area of a rectangle is length times width. So you need to figure out what your length and width are, your length and width, your length and width. Find your three areas and add them together. Next page.
There's some friends that asked for paper. I put it right there.
Okay. Next page is our, we don't have a rectangular prism anymore. Now we have a triangular prism. So if we think about the nets that we have to make for a triangular prism, it's going to look different than our net for our rectangular prism. We're going to have a rectangle for our bottom, a rectangle for each side. So we're going to have 3 rectangles. What is our end shape going to be when we lay it flat? Adeza? Triangles. Then we have to label each side. I know that my long edge of the rectangle is 14. And look at the length or the measurement for each side of my triangle. They are all 5s. My rectangle side, that matches up with my triangle side. If this is 5, this has to be 5. So my rectangle sides need to match up with my triangle sides. Now I need to find the area of each side. My rectangle area is easy. Length times width. Who remembers the formula of the triangle area? Matthew. So we call it the base on a triangle, base times height. What else do we have to do to it? We're going to divide it by 2, or we could say 1/2 the base times the height. Because a triangle, if we look at our square, the triangle is half of it. So base times height, instead of the side, we don't want the side, the height is 4.3. So we're going to do the height times the base. And then we're going to divide it by 2. We're going to take 1/2 of it. Will.
So sometimes I like the opposite, and on that one, the wings are on like the.
It depends on what the final shape was. This one, it's each of the rectangles were the same size, but if we look up there, they're not all the same size. So that triangular prism was a little bit different. So yes, triangular prisms can be different, just like rectangular prisms could be different size rectangles. Those can be different size rectangles. So I went based off of the shape of triangle that was on the page. So to find that surface area, you need to find all 5 areas, add them together. Now our next page, this is important because we have a new formula to know. Because now we're finding the volume of a triangular prism. We know that to find the rectangular prism is length times width times height. So with the triangular prism, remember it was base times height. Now we're adding in our length. What key thing do you think I have to do to it? Grace? Divide by 2 or multiply by 1/2. They mean the same thing. Okay, because it's not a full rectangle, so we can't just do length times width times height. We have to do the base times the height times the length and divide it by 2. Find the 1/2 of it. So we're going to have 1/2 of 5 times 4.3 times 14. That answer is going to go there. There are 3 inches that we multiplied together, so it's inches cubed. So you're going to find the answer and put it as inches cubed. Now, key thing for the pre-algebra. It says the base, the width, and the height of the prism are each increased by 2 inches. What is the surface area of the new figure? Not what is the volume. So we're not doing volume. We're doing surface area like we did on the last page. So you need to think of what the area is of each new side when it gets bigger, and then add all of those together. So make sure you do surface area. Jude.
Wouldn't it not be 1/2 times base times height times length, because you just do 1/2 times base, and then you do the 1/2 times base times height times length. So it would just cut the base in half.
It doesn't matter which one we cut in half, because we're getting a half. So when I looked at it, I said, oh, I'm going to take a half of 14, because I know that's 7. So I did 7 times 4.3 times 5. It's the same thing as if we multiplied all those together and we divided it by 2. You could divide whichever one by 2 if there's an easy one that you could do mental math with.
Okay.
Less putting it into the calculator. All right, next page. Pascal's triangle. The figure on the right is the first 11 rows. The top row is 0 of Pascal's triangle. So a value is found by finding the sum of the 2 values above it. So we're going to have a 1 there. Zeros are on that side. So 0 plus 1 is 1. 1 plus 0 is 1. 0 on the sides. You don't have to write those zeros in. We just know.
Actually, 0 on top instead of 0 on top.
Yeah. And I get what you're saying. I'm helping us out. Some of us looked it up. I was pretty impressed when I was correcting early. Some of us Googled it, and we're teaching ourselves Pascal's triangle, which is awesome. But I'm just showing you, you're right, 0 on top, but then we're doing 0 plus 1 is 1. 1 plus 0 is 1. So all of these outsides are all going to be 1s, because we're adding a 0 to what's on top of it. So 0 plus 1 is 1. Then we go back up and we say 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. And we're going to do it for all of these. 3 plus 3 is 9. 3 plus 1 is 4. So for all of these inside ones, you are adding the 2 sections on top of it and filling in that number all the way down to the bottom. Jude.
You said 3 plus 3 is 9. Not 7.
Oh, thank you. Because I'm going too fast, because I want to get done with the video before announcements start. Thanks for that catch. Addie.
So if you said you would have, if we had 0 on top, should we change the 0 to 1?
No, this one is going to be 1.
Okay, so we should change it if we had 0.
So the zero's up here. Because if this was a 0, 0 plus 0, all of these would be zeros.
Oh.
So this has to be 1. It's a 0 around
I
it.
got it.
Okay? Lucas?
Is it okay if I do more than the first 11 rows?
Sure. This whole thing is 11. You have to have this whole thing filled in. So if you're going to add to the bottom, you can add to the bottom. My answer key just has this triangle filled in. Mean, median, and mode. Things to think about. You need to find the mean, median, and mode of these percentages. Then our question is, if there is one test remaining, what is the minimum score the student needs to earn the Euclid to get at least 90%. So you're going to look at what the mean is with 9 tests, and you're going to figure out what that 10th score has to be in order for them to be at 90% of our scores. Matthew? No, you can't say the score. We're not giving answers, hon. Last page, I believe the last page is the polynomial. Yeah, and we know how to fill those in. So if you are watching at home, we hope you are well. We hope to see you soon. If you continue to have questions after watching the video, check in with me and I can help you. Watch the video. If there's still questions, then check in with me. Have a wonderful day.